Inverting amplifier. We've got two formulae which you find on the formula sheet, the general one for voltage gain and the specific formula for this circuit. This is a circuit diagram where we've got Rin going into the inverting input and we've got RF going between the output and the inverting input. Non-inverting input is connected to 0 volts. An explanation of this, well, first of all we got negative feedback makes the inputs the same unless the output's going to be saturated. And we know that we got 0 volts here at the non-inverting input, which means that the inverting input's going to be also 0 volts. This is known as a virtual earth. It's not directly connected to 0 volts, but it is at 0 volts. So I'm going to put some numbers in to complete the explanation. Okay, so first thing we can work out, we've got 2 volts on this side of Rin, we've got 0 volts at the other end. So we can work out how much current we've got flowing through it. Put the numbers in, 2 volts at one end, 0 volts at the other end, divide by the resistance, we get 0.4 milliamps. So that current can't go into the input of the op-amp because it's got infinite input resistance. So it's going to go through RF. We know we've got 0 volts at this end, we're going to lose I times R across this, and this is the value of V out that we've got. So V out is the 0 volts minus the voltage across the resistor. So let's put the numbers in. And we end up with minus 6 volts at the output. Okay, let's put it into the voltage gain formula, and this works out as being a gain of minus 3. So let's do some examples of where we'd use this. So we've got this circuit here, we've got 2 volts going in, we've got Rin and RF as shown. So the first thing we can do, using the formula, we can say that minus RF over Rin, if we put the values in, minus 10k divided by 5k comes up as a gain of minus 2. Using the top formula, rearranging that, V out is going to be the gain multiplied by V in, so it's minus 2 volts times 2 volts. So V out in this case is going to be minus 4 volts. Next example, we've got V in and V out, and we've got to come up with suitable values for Rin and RF. So use the top formula to work out what the voltage gain is. Minus 6 volts divided by 1.2 comes out as minus 5. So we know we've got a gain of minus 5. Using the second formula, we know that the gain is equal to minus RF over Rin. So in other words, if we know the gain, we can work out RF and Rin. So we're going to make an assumption. Assume that Rin is at least 10 kiloohms. The exam board would accept anything between 1 kiloohm and 1 megaohm for resistors. So let's just assume 10 kiloohms. How big is RF going to be? RF is going to be 50 kiloohms, so that 50k divided by 10k will give us 5. There we go. So, next one. What we've got is we've got a graph of V out against V in. Notice that what this is, it's a straight line going through 0. The slope of this would tell us the gain, and we saturate at plus or minus 13 volts. So choose a suitable point on this. I've chosen this as my suitable point here. When V in is 5 volts, V out is minus 7.5. So using the top formula there, we've got gain is V out over V in, minus 7.5 volts divided by 5, and that gives us a gain of minus 1.5. And from here, we can then do, in the previous example, we could work out suitable values. And then the final example, we got the values here, we've got to draw the graph of V out against V in. So first of all, let's use this formula here. Let's work out what the gain is. Minus RF over Rin, and that's going to give us a gain of minus 2. Next thing we've got to do is we've got to choose a point to plot on there. So let's say when V in is 5 volts, V out is going to be minus 10, and that's going to be this point here. So our line is going to go through this point. Now it's going to be a straight line going through 0. So that's a straight line going through 0 and going through the point that we've chosen, and saturating at plus or minus 13 volts.